expect a year over 1.5, probably next year or the year after. Expect a couple of years in a row as we go on, and then La Nina hits and we drop it back.
Okay, well, good evening, everyone, and welcome to Environmental Coffeehouse. And I am your host, Sandy Shellis, and let me tell you, this is an epic night. Two people that I love very much. I have learned so much from Eliot Jacobson and Jim Massa, and now the two of them are here with me. I can't be more happy, actually. And we are going to go through a whole lot of science. And I mean, you could call it nerd night, but it doesn't matter because we're all nerds and we love it. But it's going to be a learning night, a good discussion. And I'm very happy that all of you are here. And before I give it to the guys, I just want to let you know that this is the month I am doing the fundraiser for the Pasadena Animal Shelter. And so far, I think I have a little over $200, guys, and it's great because everything this channel gets is going to Pasadena. So, and in our names and whoever, whatever. So we'll talk about that at the end, but I just wanted to let you guys know. So anything you donate, don't forget. And if you want to, make it quick, or you can do it through PayPal. All right, Eliot, Jim, who wants to start out and say howdy? Howdy, howdy.
Gosh, I'll start.
Okay, gosh, go ahead, Beaver. Gosh.
Professor always have something to say, right? Yeah. So it's just an incredibly crazy time to be alive. It's an especially crazy time. I mean, I'm having a hard time enumerating all the reasons it's a crazy time to be alive. And, we're only 3 weeks into 2025, but, living here in Southern California, for people who may be wondering, I am about 80 miles north of where all these fires have been. It hasn't rained here this year. It hasn't rained anywhere to the south of us this year. It hasn't. We're now in a record drought, over a short period of time. The temperatures are in the 70s and the skies are blue, and we're expecting more winds to come through here starting next week, Monday or Tuesday. So just, I'm safe and sound out here, but everything you're sort of suspect. Yeah, everything. Right. Here's the thing. 2017, the Thomas fire came through right where I live. We had to evacuate, burned to about a half mile of our house. At the time, it was the #1 largest fire in California history, right? 2017. It's now ranked number 10.
Number
largest.
10. Oh, my gosh. That's insane.
Yeah. So anyway, it's just a interesting time to live in this part of the country right now. Everybody's talking about fireproofing their houses, and we're packing our to-go bags. We're making sure we have all of our important papers. Kids, pets, whatever it is. It's sort of like that thing we envision collapse is going to be at some future time, where you kind of don't know what day it's going to happen, but you kind of know it's going to be pretty soon, and you get everything ready.
Yeah, I've done that, quite frankly, because we've turned into Tornado Alley. We get so many tornado warnings now in the southern tier of Western New York. You know that. Well, one hit me in 2017 and destroyed. I had old growth trees. The property was a mess. Smashed my ex-husband's pickup truck, smashed the deck. So now when we get the tornado warnings, I've made a safe area in my basement with the 8 cat carries. Imagine herding 8 cats into cat carriers. It's not going to happen.
You can do it.
I could try. But I mean, I do that, And Jim, what's going on in Alaska? Howdy. We don't want to forget you're here, hon.
We're having a wee bit of like weather whiplash up here. Last weekend we had some strong Chinook winds blow through. Now, Chinook winds is something that does take place here in Alaska at some point, usually in February or January or something like that, but not to the point where it takes temperatures that were pushing minus 30 and setting record high temperature of positive 44, which is what happened. We set a record high temperature. So that's a 74 degree swing. And if anyone wants to know what a 74 degree swing feels like, imagine 30 degrees becoming, 104 degrees.
No,
just
thank
to put
you.
that in perspective.
Yeah.
And so there was a lot of snow rumbling off the roof. So the snowpack on the roof got kind of dumped. And then it dipped down to minus 23. And it's now whipping back up to positive 6. So we're just having these wild fluctuations in temperatures because, the jet streams are all screwy.
Yeah, we're going to get an Arctic blast. It was 30 today, but next week, of course, the day I have to go out and travel an hour and a half each way, 3 hours, is going to be minus 7 Fahrenheit. Of course, And already yesterday, because it was yesterday, I went out. I don't go out very often. I had the defrost on. It was very cold, and my windshield cracked. It cracked from the weather. Yeah, because I didn't know why it cracked. My brother says, well, don't you know, you turned on your defroster probably too hot and the windshield was too cold. That was that. So I have glass coverage, thankfully. But I mean, this is the shit that's nothing. That happens. But I mean, we are all experiencing it everywhere. And it's changing. Like I said, Eliot, you were surprised to hear that I feel like I live in Tornado Alley, but last summer the tornado warnings were crazy. And when I see those dark clouds, I feel like it could happen. I have a bit of post-traumatic stress disorder from that. It's scary. So I've got an area, I've got a box, I've got everything already, but I'm a prepper anyway. So yeah. All right.
So Eliot, the Santa Ana winds, have they been moving any of the smoke towards where you live?
So the Santa Ana is kind of the general direction is from the northeast towards the southwest, and so I'm northwest of the fires. So we had one day where they sort of blew the other direction. We got some smoke, air quality index in the 50s type of thing. But other than that, not bad. But anywhere down south of us, it's glaring red AQIs in the 200s or above. It's insane down there. And these Santa Anas are that's the really sort of weird thing here. It's like they can pick any random part of the coastline to blow, right? It's not like they have to blow through Los Angeles or Ventura. We can get them here. You can get them up to San Luis Obispo. You can get them down towards Orange County. Wherever they are, that's going to be ground zero. And
oh my God.
There's this new terminology. I think it was invented in 2020 or 21, called a PDS, right? A particularly dangerous situation. And that's sort of above a red flag warning, or that's when a hurricane is coming your way, Cat 5, and you got a day to prepare. So we had one PDS in the 4-year span, 2020 to 20 or 5-year, I guess 24, right? We have had 4 of them already this year. These sort of situations where it's like don't go to sleep. Right?
That's scary. Shit.
So yeah, we've had 4 PGS warnings already this year.
Jim, what happens up there that could be very serious that you're not used to, let's say? Because I know you've been there a long time, but what happens in Alaska that you would have to prepare for and maybe evacuate?
Well, we do have fires up here as well. There was one, I guess now it would be 3 summers ago. Yeah, 3 summers ago. A fire was within 5 miles of my house.
Oh,
And
okay, that's scary.
And basically, it was because it was on the other side of a ridge. It's why it didn't go up and over the ridge and come tumbling down. But it was salmon colored skies,
Ugh.
and difficult to breathe.
There was just an article, I think it was in today's paper, where they were talking about, you think Vancouver can't have forest fires, and just Kamloops, right, in Canada. I mean, the where you are can burn, right? So no question about it.
Well, let's just look at a brief history of just the last 10 years or so. We have had major fires across basically all of the circumpolar north, Alaska, Scandinavia, Siberia continues to burn summer after summer
hasn't
after summer.
stopped. Right.
Yeah.
Zombie
fire.
Yes, exactly. Look at the devastating fires in Canada last year,
Right.
and now California. We are just, the planet's burning down, if you want to be blunt about it, and because everything is drying out, and that just makes good, tinder for flames. And I have to say this, but everyone talks about the less sulfur in the shipping fuel, and that's reduction of aerosols, and this is why everything is warmer. Well, you would think that with all these fires and all that soot, all those basically condensation nuclei particles that have been tossed into the atmosphere, that would more than counteract any reduction in the sulfur fuel. So that the warming is probably because we continue to burn more and more fossil fuels, increasing in a nonlinear manner and adding more of that energy into the system. And let's not forget phytoplankton. I know I have to talk about it, but
It's okay.
Phytoplankton release dimethyl sulfide. This is a very important chemical. We've talked about how phytoplankton supply 55 to 80% of atmospheric oxygen. Well, they supply on the order about 10 to the 15 grams of dimethyl sulfide into the atmosphere every year. DMS is an aerosol. And recent research shows that when the planet cools down, they release more of it. And when the planet warms up, they release less of it. In other words, it's a corrective feedback mechanism. Phytoplanktons regulate the planet's temperature. And you don't see people including this in their modeling. 10 to the 15 is not exactly a trivial amount.
Well, it's not a zeta plankton, right?
Yeah, zeta. Yes, zeta plankton.
6 orders of mag less, right?
Aw, I know. Everybody that's new here, just so you know, zettajoule is a measurement in ocean heat, is it? And we learned this from Jim, and before I was joking with Jim earlier saying, well, the closest I would think a zettajoule was a kind of ring before I met Jim. So, I mean, here we are really learning a lot of things that we never did between Eliot and Jim on this channel and on all these other wonderful channels that unfortunately really don't get enough views. I mean, even the bigger channels that get will put out a fabulous video and get 10,000 views. That's a drop in the bucket. That's like what? Nothing. People are not.
I have a question for Jim. I want to get back. I'd love to ask you, Jim, about what you said about fires and nuclei for clouds. So my understanding is like sulfates are being released over the ocean, and so they're naturally immediately available over a source of water to help create clouds. Whereas most of the ash that's created from fires is it's significantly larger, I would think, than a sulfate. I don't know exactly, what the particulate is, and it also sort of precipitates, faster. It doesn't carry the same way. Now, I don't know that, I don't have the rough measurements, but I do look at these global maps, specifically because what I do know about fires is that they create carbon monoxide, and that reacts with hydroxyl, and it cannibalizes the hydroxyl so that the hydroxyls don't eat a methane, so that fires sort of indirectly help methane growth. But I mean, could you tell me like what is the comparison between sulfate and fires as far as cloud formation? Do you know anything about that?
Well, you are correct that the particulate sizes do differ, and depend on how thoroughly stuff burns can determine the particulate size. Yes, they tend to be larger, and yes, they can settle out sooner, but you have to look at what the wind atmospheric flows are doing. Sometimes the atmospheric flow can be sufficient to keep them airborne for a longer period. You have to look at where does the winds carry them over continents, over ocean. So there are a lot of factors involved with that. The point of it is, though, whether or not it stays as long in the atmosphere as not, it is still basically preventing UV energy from reaching the surface.
Mm.
So
I mean that's absolutely 100% true. That it's weird that fires have a cooling impact. It's like it's a funny paradox that's exactly right. I forget where it was I read about that, but it was I think it was after one of these fires burned in Canada, and it had all this smoke, and they were saying, yeah, but it was 104 degrees, and now because of the fire, it's down, to the 90s or 80s. It's so yeah,
Like the
it's strange.
Tonga effect.
I suppose that's it. But
but don't
there
forget,
have been a lot of papers just recently. I've sort of resisted, and maybe it's like you. I've resisted believing that sulfates like the IMO 2020 had any more impact than sort of what the science said was zero point zero 0.02 C or something for a couple of years. Not much at all, right? So this IMO 2020. But just recently, there have been a couple of new papers that have come out that have pegged it a lot larger. And,
Mm.
0.08C came out just today. I read about some paper that came out, pegging the
and
impact.
for what was that, by year, by decade, by what was the time scale?
It was 2023. So, yeah.
So
So
that was
so the
point oh
short
0.08
term
for 1
impact,
year.
what they were saying is that IMO went into effect in 2020, and its impact on ocean temperatures, or maybe global temperatures, I wish I remember, but it was 0.08 C as
Mhm.
of the end of 2023. So I guess it would have been over that span of time.
Wow.
Um,
Well,
so
see, there's a couple of points to that. Well, first of all, we now have a new classification of clouds called pyrocumulus. So the pyrocumulus can now take that soot and elevate it to very high levels in the atmosphere, basically to the top of the troposphere. So where they can then be dispersed further before they eventually settle out due to being larger particulates. So, and by the way, there is a scale on the the condensation nuclei particle sizes. I forget what it is offhand, but there is a scale on, for soot down to, chemical species and so on. And as I said, I don't remember what the scale is. The thing that the problem I have with, the sulfur aerosol stuff is, you have, and I think it's global average. It's not ocean temperature, is what you're alluding to there. The problem I have is that if you have 0.08 C for, say a 5-year period, then you have the same people turn around and say, well, this has now caused a 5 to 7 C increase in sea surface temperature. And that is just plain wrong, because the specific heat of
Really?
water is so much higher than air.
Thousand
So
times.
yeah, so it's just going to take a boatload more energy to, if you have the same volume of water versus the same volume of air, it's going to take a lot more energy to heat up that water the same amount, to heat up, by the same amount to heat up the air. So, and there's other things that they don't take into account. The angle of the sun rays where it impacts, the ocean surface. And you take, for example, the North Atlantic. The North Atlantic is, for the most part, not exactly a calm place. It's a lot of turbulence, a lot of wave action, which greatly reduces how much direct energy that sunlight can penetrate. And whatever the sunlight energy does penetrate the ocean, it quickly, follows an exponential decay pattern. It quickly attenuates. So the depth of penetration, depending on altitude and latitude and clarity of the water, can be anywhere from like 1 centimeter to maybe 100 meters in the tropics, where it's already warmed
So
anyway. And
who's
up at high latitude, it's going to be just a couple of meters at best.
who's doing the research on this, Jim, that you're
On what?
talking about? The information you're providing us. Who's actually doing this research to correlate all this?
No
I'll
one.
speak to
That's
that.
the point. That's what gets me going. No one is including these basic factors, these basic concepts and principles into their assessments. They're given an
Eliot?
incomplete picture.
Eliot?
I'm gonna tangent off this. I mean, one of the things that I've noticed, because I pay very close attention to global temperatures and ocean temperatures
Absolutely.
and all these things. And I've done these sort of decadal studies where what I do is I take a given day and 10 years ago to the day, and I take a delta, the difference between those two. And then I do that, for every pair of days, as much data as I have. And then you get a pretty jagged graph because today and 10 years ago today, anything could have happened. But you can do a curve fit to that. And that gives you sort of a decadal warming, if you do a linear trend line. And what's remarkable is that at this particular moment in time, the decadal warming for our atmosphere is almost exactly the same as the decadal warming for the oceans. They both come out to be about 0.3 to 0.35 C per decade, at this moment. Which, I mean, to me, I understanding that the oceans take a heck of a lot more energy to warm than the atmosphere, and yet we see the oceans warming globally right now roughly the same rate as the atmosphere, and that could be skewed a little bit by where we are in ENSO or some other impacts but the long-term trends are really matching each other. And I don't know, Jim, have you looked at that, or is that something you have an explanation
Oh
for? Because
yeah.
I would, the oceans would be a lot
Oh,
less.
oh yeah, and it's very simple, because when you say you go back 50, 70 years, uh, here it is, Sandy. You asked for it. The oceans have now accumulated over 500 zettajoules of energy. which and it's now concentrated in the upper 700 meters, which means that stratification is increasing and thermohaline or vertical flow is decreasing. So the ability of the oceans to take that heat energy and sequester it to depth is greatly reducing, which means it is now being concentrated in the upper layers of the water column, and it's now diffuse because it can't go down. It's got to go somewhere. It's got to go sideways or up, and it's going up is a major reason why we're seeing the increase in sea surface temperature, and some of that heat energy is diffusing to the atmosphere.
Sure. Yeah. Eliot, when it goes
Yeah.
into the atmosphere, it's just another cluster mess.
Yeah, okay. You're not going to get. I'm watching the comments, by the way, and Sam just told me that I should take up stamp collecting.
I saw that. He's being the ever the comedian tonight.
Yeah. Here, pick a
Yeah.
card.
Okay.
Any card, Sam.
There we go.
Okay. I just want to say something real quick.
Yes.
Someone's talking but doesn't know what a zettajoule is. Zetta is a metric prefix that means 10 to the 21. So when you hear zettajoules, that means 10 to the 21 joules of energy. So to have 1 joule followed by 21 zeros, that's what a zettajoule is.
And if I could just give some context to that,
Yeah.
that maybe would help people understand. 1 zettajoule is equivalent to about the heat from 16 million, maybe 16 billion. I got to double check that. 16 million Hiroshima bombs. So when so right now the ocean is heating the equivalent of about 16 to 18 zettajoules per year, right? That's the sort of the heat content that it's growing by, which puts it somewhere between about 250 million and 275 million Hiroshima bombs worth of heat per year.
Okay, so that's more understandable for
so
some of our people.
250 million Hiroshimas. Forget the explosive power. Just take the heat from those.
Okay.
All right. That's how much the ocean is heating up every year right now. Maybe a little more than that.
Which is insane, and that is why we are seeing the extremes in the hurricanes in Florida, down in the Gulf. Am I right?
Well, I mean, it's just, for me, zettajoules is just, it's kind of a technical term. And it's funny, I use the Hiroshima because that's what Hansen used in his TED Talk back in, whatever it was, 2008, 10, 12. And most people appreciate it. And a lot of people try and get me to use anything else but, but at any rate.
Well, here's another, you mentioned earlier the ENSO cycles. It's probably because we're in a La Nina situation right now that made the fires worse, because if for that region of the continent, Southern Cal over into, say, Nevada, Arizona, that region there, in a La Nina, you get dry conditions. And you guys are already in a drought condition. So now you have it further exacerbated by even further drying conditions. And this is just everything coming together, unfortunately, and making this thing, plus the wind, and you just have a disaster on your hands.
So Stephen says, is it spread over the entire earth, ocean, both? You need to be able to explain this to toddlers. Because we do have a lot of new people in the chat that want to learn. And Jim, you're a science teacher.
I'll explain it to the toddler. You're talking about La Nina. And what's strange about California, right? We have this triple dip La Nina in 2021, 22, or maybe going into early 23. And the 2 wettest years we've had in a long, long time were the 2 previous years that were both
Right.
La Nina years. And, our local reservoir was down to 7%, and it overtopped in 1 year,
Yep.
right?
I
Because
watched it.
of how much rain we got. And they were saying it's going to take 5 above average years or 10 above average years. And that's how much rain we got. So all of this plant growth the last 2 years, right? Because of that rain. So we're just, everything's growing like crazy. Like the wild flowers are growing like wildflowers.
Yeah.
But what happens when the atmosphere heats up is that it can hold more moisture. And there's 2 consequences of that, right? One of the consequences is when it rains, there's more moisture available for flooding. But the other consequence is that when the humidity is low and there's more atmosphere available to suck up moisture. So things dry out a lot faster. And right now, the soil moisture is at an all-time record low. They measure how much moisture is is all-time record low. I mean, we went from record rain to all-time record low soil moisture in less than a year. That's how this whiplash is crazy like that.
Yes. I do have another question from Stephen because I really like Stephen, and he has. Can we dispel the myth that we can just dump ocean water over the land because it's salt water? There's been so much talk about, oh, why can't we just put salt water? But no, can't use salt water. Do either one of you have an explanation for that?
They did use it. I mean,
but they did use it.
Flying the super scoopers right over the Pacific Ocean and
They
dumping
did?
it on the
So
Palisades.
what's the controversy about the salt in the water
It kills all the plants.
It does. But isn't that what you want to do to get the fires out? Okay,
I mean,
we're not.
you really want to be dumping toxic,
No.
I mean, not much grows on a beach, right? You think about
True.
a beach, right? You don't have a lush, sandy, all the things don't grow on a beach because of all the salt.
Right. True.
Kills everything.
I mean, I look at it this, Stephen. I had a problem with my house, and I have a saltwater, salt system for my water softening system. And the plumber made a mistake, and I was watering through the hose my plants, and everything was dying. So it's as simplistic as that. They had to come fix it and reroute it. But it is simplistic, and you're right about it. It kills everything.
And remember, sea salt spray is also an aerosol.
Oh, nobody thinks about that stuff.
But
then on top of, but look what they're,
but their geoengineering ideas, right? Is these boats that are going to shoot the.
Yes, it is. But then they're the planes are dropping all the fire retardant. So, I mean, it's going to be something. No matter what it is, it's going to be toxic.
Yeah, and that has PFAS in it, all the fire retardant, right?
Yeah, they haven't taken that out yet. Right.
Yeah.
Oh my gosh.
And someone just has a comment here, which is very good. Road salt is becoming a problem in groundwater. Well, if you start dumping ocean water over the land, you're not only going to cause osmotic problems for the plants, where you're going to kill off your crop, but then you get that salt in the groundwater, and then potable water becomes not potable.
Interesting. Yeah, we've had fights in our community not to put that kind of water on our using the salt, the road salt, or toxic sludge from the fracking. And I mean, there's always something. Hey, Eliot, there was a battery plant fire. Also, I'm wondering if you know anything about that. What kind of batteries? Do you know anything about that?
I don't, but because I'm kind of a nihilist, I was rooting for the fire.
Jeez. Okay. All right, but then what happens with the animals?
I'm not a green. If anybody thinks like I'm pro green, I'm absolutely not.
Well, we didn't know what kind of battery factory it was. I mean, was it just a regular factory that makes car batteries as they are now, or is this a lithium? We don't know. I didn't learn about that. I didn't have time.
There was a lithium ion battery,
okay.
But I don't really know.
Okay. And here's another one I saw today. So I watched a video where somebody was walking through the ruins of their house. It was really, really sad. They go through everything and everything's burned up, but yet there's a propane tank in their grill that looked like it was untouched. Everything else was burned. How in the world could that actually happen? That propane tank did not burst? Unless it was empty, but still it was metal. It didn't burn. It was really strange. I'm not saying it was like some kind of conspiracy. I just thought nobody said anything about it in the video. I just thought it was weird. No.
Yeah, no, I've got nothing.
A lot of strange things happen. Yeah.
So I'll tell you a strange thing that happened. So my wife was doing some grocery shopping, and she overheard somebody talking on the phone, and it became evident to her that this person was displaced from the fire and had come up to Santa Barbara. My wife went up to the person and said, "Oh, forgive me, I overheard you were talking on your phone, and I'm so sorry for your loss, and do you have a place to stay, and how are you doing?" And the person said, "Oh, no problem, no problem. We have our second house here in Santa Barbara."
Oh boy. Oh.
So the place that burned up, Altadena is the real crisis here.
Oh, it is.
A lot of people, very wealthy people, and I mean, certainly there's a lot of poor people who lost their homes, but there's a lot of wealthy people who have multiple residences. So I'm more saddened by the Altadena. There's this what's his name, McGregor, the fellow who does the daily videos about picking up trash.
Ewan McGregor. Edgar. Okay.
Yeah, and he's a long time character on Twitter. And every day for the last, he has 2,000 days now, he's gone out and collected trash from this public park where people just leave it behind on the trails. And, that was his thing, was to post these videos every day of going out there. And his whole park burned down. So, I mean, there's very, like it's just, that part of Los Angeles is really beautiful, right into the hills.
Oh, jeez. I've been looking at videos from, another thing I wanted to mention to you too. I watched a video from 1961 when Bel Air burned up, but it burned up it was 400 houses. And that was when they first started proliferating out into the hills. And I was using that video because back then they were complaining they didn't have enough fire people. They didn't expect it to be like this. But I'm using that video as a retort to all the people that say it's directed energy weapons and HARP, because were there directed energy weapons and HARP, you morons, in 1961 in the Bel Air fire from the Santa Ana winds that were 50 miles an hour at their height, which are now 100 miles an hour or more at hurricane force because of what we've done to the climate? Anyway, so I had to get that in.
Yeah, no, I this is fire country. It's always been fire country. Mm-hmm. Fires have a long history in
yes,
California and on the West Coast, and anywhere there's forest, honestly. But you move people into the sort of urban wildfire interface, and they have grills, and there's electric lines, and there's cars backfiring, and there's cigarettes, and there's homeless encampments, and there's so many reasonable ways for these fires to get started, given the hundreds of thousands or millions of people who are living in these sort of dangerous areas. The Occam's razor that it's some conspiracy is just, it's beyond stupid. So I have a different solution than you, Sandy. Somebody mentions HARP. I don't care how much they agree with me on everything else. I'm blocking them instantly. I don't want anything to do with that kind of stuff. And
Well, I've just been using it on comment sections sporadically when I see it because I watched that video and I share the video and I tell them there was no dew or harp or any of that when this happened. So learn, and I also try to counter it with overshoot. I've been really, really heavy on the overshooting and the planetary boundaries and tipping points. At least that's what I can do, the things that I know. But, gentlemen, you do have some graphics and some material if you want to go to that. Did you want to?
Jim, why don't you show something? One of yours.
Well, Sandy, did you get my links?
Yeah.
Okay, so I mean, it's just
Of course I
what we
did.
got here.
Nice.
Yeah, let's start with that one. We'll go with that one first. Perfect.
Okay.
Yep. This is just showing the current the state. This is as of November 14, 2024, and La Nina conditions are present, and they say it's going to be the prognosis that's going to be relatively weak, short-lived, but it's still nevertheless in effect. And scroll down a little bit, you can see it shows the El Nino and the La Nina phases of the ENSO cycle. Of course, it will probably shift into neutral before it goes back into El Nino, or maybe it returns back to La Nina. Hard to say, but you can see in the El Nino that it's the Eastern Pacific is a little Eastern Equatorial Pacific is a little warmer than average, and if you go by the in the diagrams the clouds are showing, it's supposed to be, at least historically, a little wetter over the western seaboard than in La Nina, where you have cooler than usual conditions in the eastern equatorial Pacific, with again historically drier conditions. But Eliot informed us that the last couple of years was a little different.
Yeah. Record rain. Yeah. Record rain.
But now, was that really during a La Nina, or I thought it was an El
Yeah.
Nino at that point?
No. It was smacking. I mean, we were prepared for this year. No rain, and I ended up going down to emergency services. I'm a volunteer for the the local emergency services, and I answer the phone when guy calls me up from a Vaughn's parking lot. And he says, when am I going to be able to go home? And I'm like, no, just get comfortable in your car. It's going to be a while.
Wow.
It was crazy. We got 9 inches of rain in a day, in the middle of a La Nina.
That's like nuts.
It is nuts. Is it totally nuts?
Adam wanted to know, is climate change affecting the La Nina and El Nino cycles?
I would say yes. I mean, it's disrupting, not just the jet stream flow, but you have the ocean heat. So I think a lot of this could be that a lot of the ocean heat, even during the La Niñas, somehow managed to diffuse to the atmosphere, where it could then form clouds and drop the moisture. So it's, the system has been so incredibly perturbed by human activity
Good word.
that the system is trying to find its new equilibrium state, but because the perturbations continue, it can't, and it doesn't settle in on a new equilibrium state. So we're just going to have all these, I now call it climate chaos.
Yeah, and so for the what I've read about that question is that we're slightly more favored towards La Nina now than previously, but that should flip in the neck by 2050 to more, an abundance of El Nino. So the heat is going to be stored and stored and stored, and then released in mass. all at once is sort of how the ENSO. But the other thing that's kind of remarkable, ENSO is not just about sea surface temperatures.
Mm-hmm.
It's more about wind direction, right? It's about how the winds change where the hot water is, and what's released. So every unlike these sort of 30-year temperature baselines, and we're now in the 1991 to 2020 baseline a lot of people use, El Nino actually recalibrates their baseline every 5 years. When they say we're a half a degree, 0.05 C is the minimum threshold to be in a El Nino.
Mm-hmm.
That's 0.05 above what, right?
Oh.
Minus
Mm-hmm.
0.05 C anomaly to be, or below to be in a La Nina. Well, minus 0.05 and C below what? So, my understanding is that baseline is because sea surface temperatures are rising so quickly, and you have to also correlate it with wind direction and, other anomalies. That we're already racing just to be able to keep up with the definition. And recently, I don't remember what it was, and maybe Jim does. There was actually talk about creating a whole new definition methodology for these events.
Well, you're right that the ENSO is more than just sea surface temperature. It's the location of the high and low pressure atmospheric, systems. But but everything you have the teleconnections. Everything is connected. So what happens in the equatorial Pacific affects the northern Pacific. So, for example, which state the ENSO cycle is in will determine where, for example, the Aleutian low sits. And, usually during El Nino, historically, you have the Aleutian low move eastward and sets up milder conditions for Alaska and vice versa during a La Nina. So you have to look at the Pacific Decadal oscillation as well. There is a connection between ENSO cycles and hurricane strength and frequency in the Atlantic Ocean. So it's a big coupled system. That's what people need to understand, that the atmosphere and the oceans are a big coupled system. Now, you talk about, well, it's 0.5 C above baseline. Well, the thing is, because we go with, a 1970 to 2000, 1980 to 2010, or we have these 30-year, baselines we look at. Well, if things keep warming up, the baseline just keeps moving up, doesn't it? It just keeps increasing. So that's why I like looking at the analyses that show, well, how does this compare to, say, the 1950 to 1980 baseline? And when you do those analyses, then the differences really jump out. And it's a big smack upside the head. You see the drastic changes. Something else to keep in mind: the coldest La Ninas of recent years are warmer than the hottest El Ninos of 30, 40 years ago.
Yeah. Yeah. I mean, yeah, absolutely. I mean, even the 1997 El Nino is below our current La Ninas, right? I mean, that was the monster of all El Ninos back in 97, 98. And you look at the temperature rise, and yeah, things are moving. So things are just moving so quickly. It's hard to, put it into perspective as people our age, right? We knew a time when things didn't move this quickly. So we have, the ability to sort of understand at a very physical level how fast this is, based on our childhoods, in a way that I think people who are younger, in their 30s and below they just don't, because it's always been moving fast for them. So it's like, oh, that's just how it is,
Right.
But
well, I
yeah.
think that's why I think that's why you see things like, whoa, scientists are surprised at how fast this was faster than they predicted or projected. Yeah. and you keep, because a lot of times they made the assumption, erroneously, a lot of cases, of a linear increase when it's at least nonlinear, whether it's quadratic, exponential, what have you. So, the joke that I like to say is, we'll let the tetration begin. That's the joke that I like to say.
My God. Did you want to move
Power
on?
towers.
Did you want to go on to your
Oh,
next?
sure. Yeah, we can do that. Let's see. Oh, this is just, I don't know which one you're pulling up there. Let me
The
hang on.
El Nino and La Nina local and global effects. Did you want that one, or do you want the Climate
I
Prediction Center?
yeah, we can do that one.
Which one?
I guess the one you got up there is fine. There's no real
Okay.
specific order,
Okay.
but you just scroll down there, and there's your global temperature rising, and I think it's. Hang on, what the hell is my computer doing?
Do you want me to read it? Do you want me to read it and at least get something?
My
Or
computer, hang on.
La Nina conditions are present and are expected to persist through
Okay.
February, April 2025, 59%, with a transition to ENSO. So talk about that. And again, go through all the ENSO, the El Nino Southern Oscillation. Yes.
Yeah, La Nina conditions emerged in December 2024. Below average sea surface temperatures were observed. The latest weekly indices were negative 0.7 C in Nino, 3.4, and negative 0.6 in Nino-4. So it's a couple different scalings that they use. Subsurface cooling, equatorial Pacific fields strengthened significantly. It's just given a description of what the situation is. I know you link these in the show notes, so
Yeah.
if anyone wants to get the nitty gritty details, they can just click on that link.
Yeah, I didn't put these in the show notes yet, but everything else is in there. Your channels. I mean, it's a comprehensive show note. I wrote this out. It was comprehensive, but I'll put these in. So all the links will be in for all of you inquisitive minds.
Yeah, if we can pull up the Climate Central link there. Yeah, that one there. And basically, if you scroll down, you can to the first graphic. You see what says global temperatures rising.
Yeah.
Yeah, I think we can. Obviously, you can see the seasonal variations on it, the seasonal cyclical nature. But granted, you need to do the analyses, the curvilinear analyses, and so forth. But just a rough eyeball of that fitted function seems to be, to me, be nonlinear.
So I've actually looked at that question pretty closely. It's frustrating. Like Copernicus has this website where you can sort of choose your 30-year period, and they'll fit it with a line.
Love Copernicus.
And as you go back in history, the line has a lower slope, and as you move forward in history, the slope is increasing. So if you go from like a flat slope to an increasing slope left to right, well, that's exactly the definition of quadratic growth. So, I mean, at the very least, what is happening right now is quadratic instead of linear. So it has an x squared term rather than just an x term in it.
Exactly.
So it's probably even a little faster than that. I think there's some jerk, a little bit of cubic growth going on, maybe a small amount. It may or may not last very long, but yeah, I mean, to understand how powerful quadratic growth is, that means accelerating. And every climate scientist should be using the word accelerating and not just sort of spitting out this party line that, oh, everything's still within the models, It's like, oh, look, here's the models. Well, yeah, those models, you might be in the models, but you're above the mean of the models and you're moving up towards the top of the models, and you're doing that faster and faster over time. So there's this resistance that I just I get so kind of riled up about against using the word accelerating. using anything other than linear. And the reason for that is kind of technical, because the actual response of the atmosphere to CO2 is logarithmic. As you increase CO2, linearly, the increase in response and temperature is logarithmic. It's more like a curve like this, flattening out. So CO2 is increasing exponentially would make linear temperature growth. That's all the math I'll say. The problem is that there's these feedback mechanisms on top of the CO2, right? So that all this math that these climate scientists are saying, but the math forces it to be linear. It's like, yeah, the math of CO2 forces it to be linear, but there's everything else that goes on top of that they're not putting into that when they, that is actually demonstrably shown by images like the one that Jim has up there right now. This is not linear, right? It's not linear.
Okay.
So that's my math rant. Hopefully a couple of people out there like me using the word logarithm.
Well, one other thing, that when you look at the functions that have been developed, the curvilinear regression analysis for, say, sea level rise, it is definitely a quadratic function, and it is reported as such. And as you say, if you start out with an x squared term, by the time you get to the acceleration term, you have a constant that is not zero.
Sorry.
And which means it's going to keep going. So, as you say, the quadratics, at the very least, is extremely potent, and exponential is even more potent.
Yeah.
I was just going to pull up the quadratic.
I'm in total agreement with you, Eliot, on all of that. Total agreement with you.
Yeah. Well, that's the nice thing about science, isn't it? Like, if you say things that are that A implies B to another scientist, they'll agree with you, because you don't have any other choice.
As when Neil deGrasse Tyson says, you can have your opinions, but facts are facts.
One of the things we have is we do have record CO2 growth. This just came out today, right? I don't know if people are following this in the news or not, but they just said, the last 2024 saw CO2 growth of 3.6 parts per million.
Yes.
That was the amount.
Yes.
All right. So I actually do this very careful analysis every year of CO2, or every month. And what I do is I take a 12-month running average, right?
Yeah.
A 12-month running average, and then I compare today's 12-month running average with the running average from a year ago. And so rather than just, doing a year at a time, I actually get to update this number every month. So NOAA just says, 2024 was the most ever. Well, I get to say this month is the most ever. And that actually, we actually did just hit, the fastest annualized CO2 growth ever recorded. And that is stunning, because we're supposed to be on our path to net zero with electrification and solar and wind.
Okay, sure. Yeah.
And yet, and why is it growing so fast? Well, aside from the fact that we haven't really reduced fossil fuel use, we're still pumping out more CO2 than ever before. We're also losing sinks, right? We're losing the Amazon sink. We're losing the Arctic boreal forest sinks. We're losing, so
Amazon. We're losing the ocean sink, and that's a biggie.
Yeah.
Yeah, and with every time an El Nino comes around, we had an ocean sink with 3 years of back-to-back La Ninas, right? A huge sink, and now we're getting the payoff for that.
Did you want to go through your slides?
I would love to talk about what this is, and maybe Jim has a comment for this one. I'd love to hear his opinion. So Leon Simons asked me the question. He said, Eliot, can you think of a way to make a graph that illustrates just how freakishly hot the ocean has been 2023 and beyond compared to all the years before for which there's data? So what I did is I took the record high temperatures for pre-2023 for every day of the year, and I graphed those in yellow. And so what you'll see across the bottom of this is actually starts in 2023. And if you look at that design of yellow, that exact design repeats in 2024, right? And because that's the right, so I actually have 2 calendar years and another 10 days in this graph. So the yellow is the record pre-2023. What's in white are the actual temperatures from 2023 through the present day. So what we see is that even though the yellow is repeating itself, because that's just, same thing year after year, the white is the actual real-time temperatures from 2023 till today. And what is true is that we have not fallen below the pre-2023 record high since March 5th of 2023.
Wow.
We are just a little bit more than a month away from having 2 consecutive years of all-time record high North Atlantic sea surface temperatures. So this was, Leon asked me if I could come up with this, and this is what I came up with. And wow. Kudos to him, because he's always trying to find new ways to visualize data to shed some light on it. But it just shows how absolutely freakish this is. And if you look back in 2023, how high it spiked there in the white line.
I can't push it.
Yeah, that's when it went global. That's when it was sort of the only thing anybody talked about on the news for a while, right? That's that's when all the climate scientists were caught flat-footed, and Michael Mann said it's the lack of Saharan dust, and someone else, Gavin Schmidt, said he expected it to normalize by August, and
no,
all those things.
All bets are off.
So yeah, this is a total freak show what you're looking at right here.
Okay, let's move on to the next one.
I just wondering, any thoughts on that, Jim?
Which one? Subpolar?
No. I'm just wondering if Jim has any thoughts on this graphic.
Well, the graphic is, extremely sobering. I wanted to return back to a point you were talking about, running averages. That's, when you see Cheng et al., he's the one that pretty much does a yearly ocean heat content summary and update, and should come out like any day now. He tends to publish every January, so I'm looking for that paper. What he does a lot of 5-year running averages, as well as 12-month running averages and decadal running averages of ocean heat. And the nonlinear increase is staggering. And he also breaks it down from 0 to 2,000 meters. He breaks it down also from 0 to 300 meters, 300 to 700 meters, and then 700 to 2,000 meters. So he does an overall over the entire water column, and then by different layers. And you see the heat really building up in the upper 300 meters.
Yeah, my understanding is that the only part of the ocean sort of globally that have not increased their heat content, right, have physically not, to depth increased, and the heat is just south of Greenland, right, in the cold spot there.
Yeah, where all the water sloshing
and for there,
and that's due to all the ice melt.
Right.
Yeah, that's what I just said, but I said it in a layman's term of sloshing.
And the other thing is, because of this heat accumulating in the upper layers, the oceans are stratifying more and more. So again, you can't get the sequestration to depth, but that then turns around and impacts productivity, and productivity is declining. But an important mechanism for atmospheric oceanic communication, how does, whether it's gas or heat energy go from one to the other, and this is now research is showing this, the role of mesoscale eddies. Mesoscale
Oh,
eddies
right.
are these little gyres, it could be on the order of tens to maybe a couple hundred kilometers across, but they are the facilitators between the ocean and the atmosphere. And if you look at everyone thinks that the Gulf Stream is this big ribbon, comes off the eastern seaboard, swings over, towards the Scandinavia and so forth. It's actually a series of all these little meandering mini gyres, if you will. That's what mesoscale eddies are. They're just mini gyres. Well, you can look, and they pinch off the main flow. So they rotate counterclockwise, some rotate clockwise. The ones that rotate clockwise bring material, gas, heat energy from the air to the ocean. The ones that spin counterclockwise go from ocean to the air. So you have to basically do a counting exercise, which one you have more of, and so which way is the net going to be? Is it going to go into the ocean, or from the oceans to the atmosphere? And when we see these high sea surface temperatures, it's because of the diffusion facilitated by these eddies, and these diffusing into the atmosphere, as well as increasing the sea surface temperature. So there's a lot of little physical mechanisms at work here that are, again, as I said before, the atmosphere and the ocean are a coupled system. They communicate with each other. That's why we don't study atmospheric dynamics, where you could. We have fluid dynamics, because a lot of times the same equations that describe flow in the atmosphere describe flow in the water. The only difference being the Reynolds number, or the viscosity of the fluid in question. So, but a lot of the equations, have added with the vector calculus, if you will, but the principles and the concepts apply to both equally. Well, not equally, but they apply to both. You can apply them equally. Let's put it that way.
Guys, want to take a question?
Sure, go
Okay.
for it.
Bombas Montecola.
Why don't you full screen us though, so
Full
we can
screen
all
the question? Okay.
No, full screen us.
Okay. Go back.
Share.
Okay, we'll go back. We go back. Okay.
So this to try and explain everything.
Okay, so we're going to go back here. So here's
Then we'll go back to Eliot's figures. I know Eliot has more figures.
Yeah. We can go back and forth to different scenes.
Whatever. I don't need to.
Oh, you have all those screens, all those graphs. I'm a bit reticent to ask, but what thoughts do Eliot and Jim have on the current figures indicating possible runaway heating, rather than just tracking the IPCC's worst case scenario?
So if I can go first on this, the models the IPCC uses are way out of date, right? They don't include all sorts of things that the next run of models will have in them. So I think you can't really even speak seriously about those models today. And the next, the version 7 should be coming out, and I don't know, whenever it is next year or later this year, sometime soon. But on the question of runaway heating, I mean, that needs a definition. I think we're experiencing runaway heating as it is, right? I've created 2 different models for future heating. One I run through 2050, and the other one I run through 2040. The one I run through 2050 assumes quadratic accelerating growth of the temperatures, and that shows us passing 1.5 sort of officially in 2027 and passing 2.0 in 2041. The other one, sort of more speculative, is maybe what he means by runaway. And in that case, it already has us above 1.5, which, James Hansen would agree with that. Dan Miller would agree with that. Leon Simons would agree with that. And it shows us passing 2 in the late 2030s. So, we're somewhere between those 2, in my opinion. But there is a very real possibility that most of the people who are watching this broadcast will experience 2.5 degrees Celsius or 3 in their lifetimes. And that is, extinction level heat. So I don't, it might not, runaway might not mean by 2030, and there's, everyone on the planet's dead by 2030. But I mean, in realistic terms, if 3.0 happens in the next 50 years, that's a
That's
runaway extinction event.
terrifying. It's
Well,
terrifying.
the IPCC, well, they keep assuming linearity, and they're just wrong, which is why I like what the PIK folks produce. They have their own model system that they use called Climber, and they've been, oh gosh, I think since they started in the early 80s, they started really putting all the data together, and they just keep updating it each year. But what they really do, and I haven't seen too many other folks do this, they not only just look at, oh, well, what's the ocean doing? What's the atmosphere doing? What's the methane doing? What's the permafrost doing? They look at the interactions.
Yeah.
What is happening with the interaction between, say, the Amazon, sink or source, the permafrost, sink or source? And then in some cases say, okay, sometimes they help mitigate, other times they help augment, and they put it all together. And what they concluded was, and this is a couple of years ago that when I saw the study, they concluded that we would be past 1.5 by this mid decade, in the 2020s, and that they were projecting 1.7 and 1.8 by like 2028, 2029, something like that. So that's almost in line with what you were finding.
Yeah, that's in the accelerating model, right? I'm sorry, no, in the accelerating model, no, but in the model that assumes jerk, in other words, cubic growth, right? The next step up from quadratic. If you go
Yeah,
to
yeah.
cubic, then yeah, we're talking about hitting 1.7 ish, 1.7 to 1.8 by 2030, which I mean, all bets are off, right?
Well, in some of their other analyses, they were actually projecting 5 to 7 by 2100.
And that's
That depends on how long humans last, doesn't it, to get there.
Well,
yeah.
well, there are population biologists who opine that an increase of 4C is enough to render humans extinct.
Oh
Now,
yeah,
it's not
yeah.
like it's not like, okay, it's 3.9, 3.99, 4.0. Oh, we're all dead now. It's just that we'll be dying in numbers by the time you get to 4C. Then it's just like curtains are,
Yeah.
curtain come
Yeah,
down.
the latest thing I read is that 3C is equal to a halving of the human population. So we get to
Yeah.
3C, roughly that means, and yeah, 4C is forget it.
Well, James Lovelock, he before he passed, he opined, I think he was being very optimistic. He said that by like 2070, 2075, there'll be a 75% reduction in human population.
Mm.
So if we take the current numbers of 8 billion, that means what, 2 billion it would be left by then. I said he was optimistic, but when you factor in not just the climate change stuff, but the wars, you're going to have starvation.
Absolutely.
You're going to have a lack of available clean water. You're going to have more.
Whoops. Oh, I'm sorry.
I like that.
You're going to.
Wait. I've got to play this, but I can't get it to shut off. Hang on a second. Hang on.
So we like that.
Sorry. I couldn't help myself. Oh.
And the other factors, of course, disease, pandemics, and so on. Don't forget, as the Arctic regions, as the permafrost thaws, we have no idea what pathogens are going to be unleashed. No idea.
Yeah, and then, of course, as my nephew would be more concerned about AI and what that might mean. Nadia asked a question I would like to answer, and that's
All right,
only because
let me get to Nadia's.
truly
Was it a
geek
super
about
chat
it,
one?
I would love to answer it. She
Okay.
asked me, "Isn't the curve sigmoidal?" I think was her question. I love that question. So let me just explain for what that means. Sigmoidal just sort of means flat at the bottom, curving up, hitting an inflection point, then stopping and leveling out again. All right, that's kind of what that means. So you have essentially two places that are stable, and you have a transition between those two places. It depends on what the thing is you're describing. But for example, CO2 growth is not sigmoidal. It might seem like we're going to go up and then hit some point and stay there. But the truth is that once humans are gone, there are natural sinks, including the ocean, that will quickly start bringing that CO2 down again. So the correct shape for the Keeling curve is kind of sigmoidal, but then it kind of starts dropping again when humans leave the scene. So thank you for that lovely question, Nadia.
Nadia is amazing. She's got more, actually. I mean, she's got.
Yeah, we don't want to lose everybody. You'll have 9 people left watching the show, right?
Well, I have to thank her for her super chats. Well, we could do that at the end because they're all going to the Pasadena Animal Shelter. So thank you. All right. So where do you want to go now, guys?
Well, I think Eliot has.
I just like to put up my CO2, put up my CO2 slide, okay? And I just want to take people through that because I think that's really an important. That's close, yeah.
I'm getting there. I'm getting there.
I know. I'm just. Can you hear me shuffling the cards?
Is this the one?
Yeah, that's the one.
Okay. See, I did something right.
Yeah. So I just want to point out what this is, right? This is this thing where I take the 12-month running average, and then what I do is I plot the difference between this month's 12-month running average and the 12-month running average from a year ago, right? So every point on this graph represents the difference between two 12-month running averages that are 12 months apart. And what you see on the left-hand side is then the rate of growth. And, I just want to point out, we just hit an all-time high on this graph, right? We are now growing faster on an annualized basis than we ever have before. And also just to point out, this net zero by 2050 is going to be this bottom green line there. All right. So that's our aspiration. That's net zero. And, the IPCC, the Paris, the 50% reduction by 2030 kind of goal, is often been touted that that's where we need to get to hold the global temperature to 1.5. So just for reference, this sort of golden line here in the middle, that's the target by 2030. So just as a dose of reality, I think this graph really lets you see, in very tangible terms, just how much we're going in the wrong direction in all manner with respect to CO2. And CO2 equivalent, right? CO2e is got a very similar graph, right? CO2, we are now at about, we're at 425 parts per million CO2. We're about 540 parts per million CO2 equivalent.
Yes.
If you talk about doubling the amount of CO2 in the atmosphere, that's where you get this thing called the equilibrium climate sensitivity that says double the CO2, let things stabilize. This is how much the temperature should raise. So we are effectively already there at the doubling, if we talk about CO2e. And depending on whether you believe James Hansen, who says doubling will be 4.8 C, worth of temperature gain, or you believe the IPCC and Housefather and Michael Mann, who say that doubling will get you roughly 3 degrees, right? It doesn't much matter.
No, they're both hideous. I mean,
they're both hideous, and
yeah.
we're there. So yeah, just because
Terrible.
we're talking about CO2, I just wanted to share this. This to me is like of all the things I do that are kind of mathematically geeky, this one seems like one of the
I
most
love it.
important to me.
It
That
is.
just stays below the radar too much.
And
Way
and
too
don't forget,
much.
there's also lag effect, pipeline warming, where what we are experiencing today is reflective of
Right.
the CO2 levels of 10,
10,
15
20
years
years
ago.
ago. Yeah. Put up the one for methane now, because I think that's kind of also really important. Like what happened with methane is we had this incredible spike just a few years ago. The first time I was ever on your show, I was talking about methane, right? Back in
Yeah.
2021 or early
Yeah.
22, right?
Yep.
And we were
With
heading right up
Jennifer.
to right up to that peak there, right? Of like methane's going like crazy. And again, this is a graph not of the actual methane in the atmosphere. This is a graph of the growth rate of methane. How fast is methane growing? And so what we see is that we hit a peak growth rate in 2021 or two, and then it started declining. And it's that's why methane was the only story in the news for a couple, 6 months or a year or so. Of course, Thwaites Glacier was the only story in the news, and then AMOC's the only story in the news, right? But so it actually looked like all the vegans and made progress capping wells and all is good. But what's happened, if you look right down there at the bottom, is that it's turned around again. And just there on the far right side of the yellow curve, the last 2 months, methane is starting to go up again. And this is really worth watching. Now you see that gold line at the bottom there?
Yes.
That's the Glasgow COP26 pledge. There was what they said was a 30% reduction in methane emissions by the year 2030. So that goal line represents the Glasgow COP26 pledge line.
Oof.
So just to really understand, how much we're going in the wrong direction, and I'm going to be really tracking methane closely because CO2 is now at an all-time high, and if methane turns around, right? I mean,
what are we at? 440? 440 parts per million?
For CO2 is like 427, the latest one, and methane's probably going to go over 1940 parts per billion this year.
Oh, that hurts.
So yeah, it'll be over 2,000.
That's
go
what
ahead.
Jennifer was talking about this for years, and on our shows.
And I'm assuming that they're including in the methane levels that are being measured what's being released from the permafrost, what's being released from the ocean shelf, as well as cow flatulence.
Factory farming.
That's all. And the big question is, and we talk about the Igor Samelatov, and Natalia Shakova, husband and wife team there, and the yeoman work they've done with the methane. What worries a lot of the folks who look at methane from the permafrost is, first of all, they're trying to get a handle on how much is there. So they're trying to do estimates of that, and then they're trying to get a handle on how does it get released? Does it get released slowly, or does it get released in burps or farts, if you will, in quick pulses, and what that does to the levels. So, and that's what keeps them up at night, because it's like, how much is there and how is it going to be released at what rate? And, we really don't quite have a good handle on that just yet. We have we have measurements, but we don't know the stores. And when you look at for example, the ocean shelf in the Arctic Ocean on the Russian side, there's a lot of methane there.
Oof.
And then you have the permafrost.
I'm
And
sorry.
another factor is the N2O, the nitrous oxide. That is also being released as a permafrost thaw, and that contributes further to, or adds more to the CO2e. And I think when you factor that in,
For
I think
sure.
it brings up about about 560, something like that, with the CO2e.
Yeah. Yeah, the CO2e, I actually have methane, nitrous oxide, plus all of the fluorinated hydrocarbons. So everything's in that mix. And I
So
double
SO,
checked. I was actually
you
in
have
touch with Gavin Schmidt and NASA guys over this. So yeah,
so you have
um,
SF6 in there as well.
all of
I'm
those,
assuming.
yeah, the entire
Yeah.
everything. Yeah,
Do we
I
have
wrote a
that?
whole article about it on
Oh,
my
okay.
blog.
Okay, yeah, that's on your blog.
Um,
I didn't pull it up. Boy, there's a
but
lot of questions
what you're
tonight.
just saying about like the ESAS and the permafrost methane and all those, right? When those things go off,
Still
if we
does.
use the NOAA data, they only update their yearly, methane rise. They do it every April, because their methane is lags by 4 months. So they'll get December 2024's methane in April, and they'll be able to update, the whole year. So I'm doing this every month. I'm essentially doing what they do once a year. I'm doing this every month. And, if we see this spike happening, this is a worst case scenario, right? I mean,
Yeah.
if ESAS and permafrost and all this methane starts making a significant difference in global methane, and right now it's not quite at that level. They do isotope studies, it's not quite there yet. But if it does start doing it, it's all CO2e is going to, skyrocket. Absolutely. It's bad news.
Yeah.
I'm, yeah,
Well,
anyway.
do
Well,
we
there's budget cuts at NOAA. That's why they only do it once a year. You know?
Oh, it's going to
Yeah,
get
and
worse.
who knows? I might not even have access to this data a month from now.
Well, you'll have to use European,
Uh,
and it's very frightening. It's we didn't want to do politics though, but that's
No,
not politics. That's
no.
policy. And that's what we will be talking about, policy and how it's affecting our ability to do the scientific calculations and measurements in this country. But right now, did you have anything else that I didn't show?
I'm ready to go to sleep, Sandy.
All right. Let's then go back to our screen share and not to the screen share. Let's just do the few questions because I got to do the super chats because I have to thank everybody and there are questions. Thank you, Jackie. Okay, thank you. And everything is going to the animal shelter, and you had isn't peak everything factor 2, biospheric collapse, endocrine disruptors, and other toxics. There's more than just greenhouse affected doom. Oh yeah, it's a polycrisis. And Nadia, you talk about this all the time. Thank you. And will the jet stream remain compatible with agriculture?
She knows the answer to that.
She does know the answer. All right, but she's giving us super chats for Pasadena, and that's beautiful. Eliot doesn't switching between. Oh, wait, we did that already. Okay. Kelly McCormick, thank you. Yes, everybody's hard work. And Jane, beautiful Jane, thank you for donating to the Pasadena Animal Society. I adopted my Coco there. My former neighbors still haven't been able to see the destruction. I fear the rains, for the rains when they come. And that is quite because it's going to be a mess. Because of the burn scars. Oh, it's going to be a mess. But I do want to go through, and I know Elliot's tired, so I am going to talk about this really quickly. I got to go back just really quickly. I want to show the one article on the Pasadena burned and anxious pets fill Pasadena shelter after the Eaton fire. And it is absolutely heartbreaking. And I wish that I could be that kind of rescue where I could take more than the 8 rescues I already have, and I'm not. So the least I could do is take everything that we get in donations on this channel this month, and maybe even through the next month, because these people, the stories, this will be in the show notes, but the stories are so sad. And I did donate myself my own money because I don't have much, but I donated when North Carolina happened. And I do donate a monthly amount to the SPCA that's local here, but we really have to think of them. People get a lot of help, but I'm always going to do something for the animals. And I just really wanted to make sure you guys understood, that, and that all of it. And I will show everybody when I make the donation how much it is. And it won't be a lot. Right now, I think I've got $200. Maybe now after tonight, there'll be more. But if we could get it up to $500 by the end of January, it would be wonderful. And I know there's a lot of wealthy people in California that didn't lose their homes that could do this. But the stories are tragic. And like I said, people get a lot of help, and we don't remember a lot of the wildlife, and it's not just pets, wildlife, and there's wildlife too. So that's my spiel. Yes. And it's been quite a show. There's a lot of questions. We don't have time to do all these questions. Oh my God.
If I may, another extremely concerning ramification of everything that's going on is, we've discussed this many times before, but as the oceans heat up and as they stratify, productivity decreases, which means atmospheric oxygen decreases. And we're already measuring atmospheric oxygen decreasing. Some measurements have it actually below 20%. And if the phytos die, the whole oceans die, and many people get their resources, their food source, the protein source from the ocean, that's going to lead to mass starvation. And, so we are on a trajectory that, to be blunt, will lead us to extinction. It's just, just looking, applying basic concepts of physics and thermodynamics, what have you, with the mathematical analyses, we're I think we've gone off the cliff, to be quite blunt.
Eliot, would you like to end the show and give us your ending? Because I know you're the one that's tired, and we could probably just blab all night long.
Yeah, I mean, if there's any urgent questions, I'm glad to end it. And
all right, let's see if there's anything that is really.
If there's a question that you really want answered, I'm glad to take just a moment there.
Tommy, so far the economic and ecological losses do not seem to be accelerating with climate change, but at what level of warming might be the rate of those losses start to track?
I just think it depends on where you live. There's maybe they're not tracking in the United States yet, but parts of Africa are certainly.
Canadian 100 from Veg. Oh, Veg. And go to Veg's channel. Don't forget.
All those questions about, are always so local that I don't think it's possible to put a number, on that.
Well, if you want to know about your local areas, American Resiliency, that's a channel where you can learn about that. She's wonderful. I've interviewed her, Dr. Emily Shorning, and there's so many wonderful small channels that need help. Because you know what? The big channels, they're just out of touch. And it's the small YouTubers like me, like Emily, like Eliot, like Jim, like all the people I highlight here that are worth listening to, because we're not in
How
it.
about Sam? We got to get Sam back.
But he's not right now. Collapse Chronicles. He will. But all right, so
you just have to tease them a little bit.
yeah. I want to thank everybody and thank you to my moderators. Thank you to the moderators here. I know there's a lot of questions, but Eliot is tired, and I know and I understand it. So we're going to say goodnight. I love you guys. Thank you so very much for all of the donations that are going to go to this. I could cry. And I'm not going to, but I've done it so many times. And thank you, Jane, again for another one. And Jim, thank you, everyone. We will do this again. I loved this, the two of you together. You did actually fulfill my dream to have you two. I'm sorry, but it just was very important to me, and it worked beautifully. And maybe when we do another State of the Planet, Eliot, I can shove you in the screen with everybody else on the channel too. Oh my God, what a show that'll be. All right, guys, thank you. I just want to make one thing. Antonio will be with me on Pajama Sunday. We are doing the insurance industry, and you know Antonio's a historian, and we will have a comprehensive show Sunday morning, 11 a.m. Eastern, and he's already got the presentation set up, so we're going to talk about the insurance industry and the ramifications of that in the we are so fucked vernacular, you know. All right, guys, so it is time. Oh, we didn't do a toilet flush. Oh, we can't go without the Environmental Coffeehouse flush of the day. Eliot, pick a flush. Pick a flush, baby. Pick a flush.
Trump's inauguration.
All right. Perfect ending. Okay, that's the perfect ending. All right, then I guess we are going to say good night, everyone.
Good night, everyone.
Thank
you for being here.
So
good night,
much.
Eliot.
Good night. I love you guys. Woohoo! I love you guys. I always say it. They all know. They all know how much I love them. Mwah.